Hey, things to remember, we have two types of projectile motion. We have the type where the object is projected horizontally. Okay, anytime an object is projected horizontally, what do we need to remember about the vertical information? Right, VI vertical is 0 in any situation where the object starts out moving horizontally because it is not moving vertically initially anyway. Okay, acceleration is 9.81 meters per second squared. Now, remember that for an object projected horizontally, we can make that number negative or positive. It doesn't matter because it never what? It never changes direction. Okay, if you're going to make it negative in this, then you also have to make D negative, all right, because they're both downwards. That's the catch on that one. All right. If we're dealing with something projected at an angle, then obviously it follows, okay, the arc that we talked about. All right, so there's a couple of things to remember there, and that is that this triangle here, okay, that this side is V horizontal, and that this side is VI vertical. All right, whatever that angle is, we can use to calculate those other sides. Okay, remember that the maximum height occurs here at the halfway point. That means that time is 1/2 of its total value, and that VF at that point is 0. Okay, got to remember one or the other because there's two ways to solve for that. Okay, if we're solving for the entire distance, obviously then we would need the time. Okay, other things to remember for both is that the vertical information, okay, accelerated motion, for the horizontal part, okay, we're talking about moving at a constant velocity. Okay, the object does not change velocity in that part. Okay, is that ringing a bell for everybody? Okay, because we haven't had a lot of time to just work on problems. It's mostly been talking about here's the different ways and things like that. Okay, now we just need to practice that stuff so that we can analyze and solve these problems quickly, right? Because that's obviously what we're going to need on the unit exam, where, as I told you on Friday, there's one of each. Okay, there's one horizontal and there's one projected at an angle. All right, so today is kind of coach practice day. So if you have questions or you're stumped on something, then just come up to my desk and ask. Okay, bring it up with you and I'll give you a hand with it. All right, but today is let's work out all the kinks and find out where all the problems lie, okay, so that we can squash them like bugs and move on. Okay, all right, any questions? All right, so you're working on the projectile motion worksheet, which I will put up on here. Okay, there's plenty of stuff on there to keep you busy for the day. All right, so remember that that worksheet booklet is in your course materials here. Okay, and you are looking for the Kinematics Worksheet book, and it'll be near the end of that. All right, so it's there on, starts on page 9 and goes to page 10. All right, I'll blow it up a little bit. Okay, I think we got through like 1 and 2 the other day, and we didn't get much further than that. So, all right, if there's questions, just pop up to my desk. Okay, so if you're not on number 11, that's fine. We're just going to go over because it was asked for here. So it's thrown from the ground into the air at an angle of 30 degrees. Okay, so this angle here is 30 degrees. The object reaches a maximum height of 5.75 meters. Okay, at what velocity was it thrown? So I'm looking for this. Okay, what I know right now, and I don't even need any horizontal information. This question is just asking about vertical stuff. Okay, so I'm going to write in what I know vertically. I know that the acceleration is negative 9.81 meters per second squared. I don't know what VI is, but I'm going to find it. Okay, but I know what VF is. What's VF at this point? 0. Okay, and I know that at that point, the displacement vertically is 5.75 meters, and that's positive because it's up. All right, with that information, can I find VI? Yes, I can, which means I would know this side of the triangle and an angle, which would allow me to then calculate the hypotenuse. So I'm going to use this formula, VF squared equals VI squared plus 2AD, because I have acceleration, displacement, and velocity. All right, I'm going to look for initial velocity by doing this. VF squared minus 2AD equals VI if I square root it all. All right, so that's going to mean 0 squared minus 2 times negative 9.81. Key that you make that negative. If you don't, your calculator will be getting very upset with you because you'll be trying to take the square root of a negative number, which is impossible. Okay, times 5.75 meters. Okay, so when I do that, all right, I'm going to have square root of 0 minus 2 times negative 9.81 times 5.75. All right, so that tells me that VI is 10.62 meters per second. Now that I have that, I can calculate what my hypotenuse is. Since it's 30 degrees, I just have to multiply that number by 2, right? Because the sine of 30 is 0.5. If I divide by 0.5, it's multiplied by 2. Yeah? Okay. Any others giving us trouble? 15? Okay, so this is like the one we did the other day. It rolls off a 32-degree incline at the top of a building. Oh, okay. So you were doing it right. See, use the wrong number. Okay. Hey, any others? 12? Okay, so on number 12, okay, again, another projected at an angle, right? So this is 35 degrees. They don't tell us what this is, okay, but they do tell us that the total time is 9.26 seconds. So we're looking for the thrown velocity. The only way I'm going to get that, since they don't tell me how far it travels horizontally, is with the vertical information. This is a math trick. Okay, what I have to understand about this is that VI equals negative VF, right? They're the same number, but VF is the negative of VI, all right? Which means they have the same what? Starts with M. Same magnitude, all right? So that means I can use this formula here. So I'll have VF minus VI over T. I know the acceleration because it's 9.81, negative 9.81. I know the time, it's 9.26. And since VF and VI are the same magnitude, really what I'm saying here is negative V minus V. So then I can solve for V and plug it in, do trig after that. Okay. I think we went over a trick like that last week, but I think it was just kind of in passing as opposed to we actually ran all the way through it. Okay. Any other ones that are giving us trouble, guys? Okay, keep going then. Okay, so for number 10, okay, we have object thrown from the ground into the air with a velocity of 20 meters per second at an angle of 27 degrees. So they gave us the projected velocity. This is 20 meters per second. Okay, this is our 27 degrees. Okay, we're looking for the maximum height that the object would attain. All right, so a couple of things we have to remember about the maximum height. And I would say for this one, the most important thing to remember is that VF is what? 0. Okay. All right, or time is half, but it's more work to calculate the time. This is going to be, I calculate VI, and then I can find D right away without doing an extra step. So what I would say here is first, let's find VI. Okay, so VI, I don't need any horizontal information to do this question, incidentally. Okay, I need nothing there. So VI is going to be the sine of 27 times 20. All right, so we've got 9.079 is our initial velocity, and that's up. Okay, I know that VF is 0, and I know that A is negative 9.81, so I'm just going to do this. I'm going to use VF squared equals VI squared plus 2AD. Then I don't have to find the time, save myself a step, and just solve for D. Okay, so D will equal VF squared minus VI squared over 2A. Okay, and so for this question, that means 0 squared minus our 9.07 squared divided by 2 times negative 9.81. And it's crucial that the 9.81 is negative when you do that, okay? So we'll have 0 minus our answer squared, okay, divided by 19.62, okay, and that should be negative, and I forgot to make it that way. All right, so we're looking at a maximum height of 4.2 meters. Yeah, right. I mean, you could also find time for the whole trip, divide it in half, and then solve for D. But again, that's a lot more work. I would say this is the more efficient way to do it. All right, any others? Okay, you know what? I'll give you a 5-minute break. Check your snaps, whatever. Okay, 5-minute break, then back to work.